Good afternoon. This is Dave Roberts, and I'm happy to welcome you here today for the Google Earth Reveals the Bigger Picture in Emergency Response webinar. My name is Dave Roberts. I'm the Senior Program Manager of the Technology Center at the International Association of Chiefs of Police. I'm very happy to be here today to moderate this webinar. Our interest here is not really to endorse any product or company, but rather to highlight the innovative application of technology to address critical justice and public safety challenges. The Maine Emergency Management Agency, MEMA, has developed a comprehensive common operating picture that layers location-based information on a single virtual globe. Virtual Maine enables emergency response teams to make faster, smarter decisions that can make the difference between success and failure when it comes to responding to a disaster. Virtual Maine enables emergency managers to analyze, visualize, and share critical information in crisis and disaster situations. It integrates mapping tools and infrastructure data across systems, agencies, and jurisdictions, providing a common operating picture for effective analysis, planning, and tactical deployment. It enables emergency managers and first responders to dynamically build and integrate additional databases. For example, water resources, medical facilities, and the location and operation of utilities whenever it's needed, and to create custom layers with private data that can help leverage security for those who need it while sharing relevant data with the public. Virtual Maine also supports first responders and public safety officials in the field by providing better situational awareness and coordinated response. It supports field data collection and operates on a wide variety of mobile devices, so emergency teams can access critical information and provide real-time updates in dynamically changing circumstances. Virtual Maine is not an application, but rather an integration of systems, data, and resources. It's a cost-effective and secure suite of tools that can greatly expedite development and implementation, providing both agility and elasticity, enabling you to customize and optimize the common operating picture for your specific environment. It relies on GIS tools and resources that are broadly available, widely used, and simple to understand. It supports community engagement by incorporating social media capabilities, and it's cost-effective, leveraging existing applications and data and integrating information from multiple sources. A word or two about our webinar this afternoon. It's going to run for 1 hour. We'll conclude at 3 o'clock Eastern Time. We have about 600 people who have registered, over 600 people who registered for the webinar. We're at about 259 people who have already dialed in. You'll be able to post questions on the dialogue screen on your computer, and we'll make every effort to raise these questions during the presentations or immediately following. In addition, we'll also reserve some time at the end of the webinar to address any further questions. And the webinar is being recorded, and we'll send an archived version of the webinar to everyone who's registered within the next 2 days. I'm pleased now to introduce Christopher Crute, who is the Enterprise GIS Applications Analyst for the State of Maine Office of GIS. Christopher has been providing enterprise GIS solutions since 1989, and did his first work in the emergency management field, developing the Maine oil spill information system in 1991. Christopher will describe the operational needs and business objectives associated with building Virtual Maine and discuss the phased development and deployment of the system. I'll provide a quick overview of the system and walk through some different scenarios demonstrating how Virtual Maine will support emergency response in different operational contexts. Finally, he'll also discuss the status of the program, business benefits, and next steps. Christopher?
Hi, this is Christopher Crute. How are you today? Give me 1 second. Got to get my screen switched over here. Can you see my screen?
Yes, we can.
Okay, I'm Christopher Crute. I'm the Enterprise GIS Applications Manager at the Maine Office of GIS. We provide support services to the Maine Emergency Management Agency, as well as other state agencies and other organizations within the state of Maine. I'm going to provide you with a quick overview of Virtual Maine with a brief slide presentation. Next, I will provide a live demonstration of Virtual Maine, and you may submit questions at any point during the presentation, and I will answer those as time allows. The context with which Virtual Maine started is that, as you can see in these red circles, we have a variety of data. We have our statewide incident management system. We have a lot of data that the Maine Emergency Management Agency manages themselves, a variety of imagery of different resolutions, utility infrastructure, a variety of field data, Canadian data, which we need to be able to access, and WebEOC, which the emergency response people use. And in Maine, we're fortunate in that WebEOC is used at the town, county, and state level, as well as a variety of EMT, emergency ambulances, and other type of services. And all of the data that they enter during an event rolls up into WebEOC. The first phase of the project started with the Public Utilities Commission, and they received a grant for electrical energy resiliency. And the primary objective of this was to enable the automatic transmission of utility outage data to Virtual Maine, and to look at that in relationship to the utility infrastructure data and some other systems that we have. And we wanted to do that from a single point of access and viewing. Phase 2 was to look for a permanent home for this. Since the initial funding was from a grant, we needed to make sure that the program would continue. The Maine Emergency Management Agency agreed to become the home for this system and to ensure its continuing operation. They had a few primary things they wanted to have added for the second phase. Integration with Canadian data was very important, as we have a very strong relationship with Canada. Integration with the Department of Homeland Security's FEMA IPAWS public alert system. Better imagery where we have it. Continuing the electrical outage project. Integration with WebEOC. Providing a lot of input and participation within the Department of Homeland Security's Virtual USA New England pilot project, which started last winter, and we just are finishing our first kind of capstone event this month, and we'll be working with the next couple months to wrap that project up. And the automating of near real-time data and developing training materials. The third phase is to fully integrate with the Virtual USA and to have a strong focus on field data collection and integration with the Red Cross. This slide is giving you a brief overview of the organizational structure. We have MEMA here in the middle and Virtual Maine. The Emergency Operations Center has approximately 40 seats, and they're populated by MEMA staff that play a variety of roles: operations, planning, logistics, communications. We also have a variety of state organizations, labor, DEP. We also have the Department of Conservation, Department of Transportation, and many others. And next we have MEMA staff that are not in the EOC. However, they are support staff and they have access to this on their desks. Next we have 24 mobile command vehicles that are operated by the agencies that you see here in the green on the right. And on the red branch here, we have our partners, the Association of General Contractors, Verizon Wireless and other wireless providers, and any other type of industry or private business partners that we might need to help repair roads, get infrastructure back in place, provide transportation services, etc. In the blue branch on the left, we have other government agencies. We have broken those down into federal, county, and metro local. And you can kind of see the breakdowns here. I haven't listed all of the detail. The idea of this slide was to show that we were initially able to sit down and identify just under 700 kind of named users. And giving us a framework on what we needed to start with, and then knowing that in the case of a very large situation, we might need to have several thousand people, and so we needed to get a handle on the number of users. The biggest challenge we had is the same as in just about every IT project that I've ever been involved in, and that is people. Working with large numbers of people in the diverse organizations. We're not really using any really super fancy technology, and that was one of the real benefits of our choice when we chose our product. We reviewed a few different projects, and we had the users review the products, and we had technical staff review the products separately. And as you can see, Google Earth was chosen by the users because it's simple. There's over 1 billion downloads of Google Earth, and if someone hasn't used it, it's very easy for them to learn. On the technical side, we could provide them with a usable solution off the shelf, and we didn't have to do any large application development, which can be costly. Instead, we focused on the development of a variety of small scripts which were used to integrate Google Earth Enterprise with WebEOC, FEMA, and a lot of other applications. Knowing that we were providing people with a system that they had not had experience with yet, we need to make sure that we could add more tools and also expand it to more users. And we had to consider the ongoing lifecycle costs, which were manageable and somewhat predictable since we did not have a large custom development, which can be hard to migrate when new software versions come out. Security is a significant issue, particularly with the utility infrastructure. We have two primary forms of security. We use Microsoft Active Directory within the state firewall, and outside of the state firewall, we use Apache HT-Digest, which is an open source solution. And with that, I'm going to move into the demonstration. Keep in mind that you are free to ask any questions at any point during the presentation. I'm going to start by showing you the primary organization that we have for virtual Maine. We have MEMA, and we have our MPUC, which is the Public Utilities Commission, power outages, and we have our statewide incident management system. As I go through the demonstration, I will give you a sampling of some of the data that's in each of these. We won't have time to cover it all. First, you can see that we have this gray area here in New England, which represents a higher level of image quality than we have for the rest of the country. We did that because of the space and efficiency. One of the scenarios that we're going to look at is floods, and our primary first data set for looking at that are the Usgs stream gauges. As you can see, we have those for New England and going over into New York State. Often, this is very important, as in the case of Hurricane Irene or other large storms that can cause events in a wide geographic area. We've symbolized these customly so that you can do a mouse over and it will show you the name of the gauge and the percent of flood that is happening, which makes it very easy for the users. And we're going to start our demonstration here at the Mattawamkeag River. And you can see that when we click on this, we get the gauge number and the gauge height, flood stage, percent of flood, and whether it's decreasing or increasing in the amount. If we click on this link, it will bring up the information that one would normally see if they went out to the Usgs site for this particular gauge. And you can see, I'm just going to scroll through here, that there's a lot of information. However, in order to make a decision quickly, it's not necessarily the most effective. The head of our emergency management agency informed us very early on that there's times when he needs to make a decision within 2 minutes. Once we know that we're having a flood, then, so we're going to assume here that this gauge is showing us that we're near flood stage, and we want to look at what's downriver. We're first going to look at utilities. One of the things that's very beneficial with this platform is that we can add databases. So I'm going to add another database here, which is our secure utilities. I have authorization to see this. Anyone else that logged into this database that did not have credentials would be prompted for those credentials, and they wouldn't be able to access it. This was really important in getting the utility infrastructure data from the utility companies, as they have a lot of valid reasons for not wanting to have the public or other utility companies see their data. It's one of the reasons that I've picked a very small area here as well. I won't be showing you the infrastructure for the whole state. What I will show you, I think, will be indicative of its value. First, we're going to look to see if we have any substations nearby that might be affected, and we can see that we have one here. We can click on the substation, and it will tell us the utility name is Bangor Hydroelectric, and the name of it, which they've named the Mattawamkeag, so that we can call them and inform them that that particular substation may be at risk. We then may want to zoom out a little further and look downriver, and we can see that we also have a number of substations downriver. Another data set that is very important for us to look at is our transmission structures. And we can see that we have a primary transmission corridor going down through this area, and down in this area where we saw the substations, we can see that we also have the transmission structures, sorry about that, that come down through there. I'm going to be turning some of this data on and off as I go because the utility data is a very dense data set. One of the other things that we are interested in, once we know that we may have electrical impacts, is to look and see if we also have any natural gas utilities within that area that may be flooded. And one of the first things that we want to look at is our distribution lines to see if we have any distribution channels for the natural gas that may be affected. And so we're looking and we're going down the river, and we can see these kind of gold here. You'll see if I turn it on and off in this area, it will go away. And so that's the first area downriver where we have gas and electric in the same area. Of course, we have overhead electrical lines pretty much everywhere, and we can see that there is an impact, and that the loss of power in this area may affect these substations, which may then in turn affect these gas distribution lines. Once we know that we may have an impact on the gas infrastructure, we also want to know where the different service taps are, and we can turn that on, and we can zoom into these and click on any one of these, and it will bring up the name of that particular one and its name, the description, when it's been in service, and so forth. This information will enable people that are planning to identify the different utilities that are at risk and to talk with those utilities to try to develop a plan for emergency response. In many of these areas, the Emergency Management Agency, its partners, and the utilities have predetermined plans. I won't be showing you those at this point. However, they do exist, and they're continuously working on those as we develop this product and provide more integrated information. The next thing I'm going to show you is an example of how we might be using the power outage information and its relationship to human life and how to manage events. I'm going to turn off my utility infrastructure data. I'm going to zoom back out here, and we're going to turn on the virtual. We'll open up the virtual Maine data tree here, and I'm going to turn on our outages. And this is a demo data set. We don't have all these outages at the moment. One of the things that's nice with Google Earth is that you can be far out and see these, and it will let you spider those out and see an individual one, or zoom in closer if that's your desire. Now, when we look at this, we can see that there's high concentrations here. I happen to know that this area is very rural in Maine, And so this is an area of concern to us. The more populated areas, the chances are of people getting help are higher. So once we know that we have the outage, we're going to want to look at a number of different things. We are going to want to know if we have any road outages, and our 511 system shows that. And since we don't really have a storm here, all we're really seeing is that we have a width limit here. I'll zoom back out just for a moment so you can see that it does in fact show all different types of information, and we have it for New Hampshire and Vermont. These particular signs show that a road is closed, and we have things when it shows it's reduced to one lane. We also have cameras, live camera feeds in a variety of places around the state, and I would expect that during a severe storm in this area, we would have roads and other types of transportation infrastructure, perhaps bridges, that might have been impacted. Another thing that's very interesting to us.
Can I jump in for 1 second here? We've got a question I want. You can probably address it right now. When you say database, do you mean geodatabase that you can create in ArcGIS? Can you also add shape files?
We can. So we can come up here to the add data, and we can go out and we can add a variety of data. So we can add network links here, and any URL, a network link, that web mapping service and so forth that you have, you can do there. We can also come over here to the file import, and with the file import, we can import a variety of different types of files that you can see here, from text files, shape files. I'm not going to read them all. You can see here there's a really wide range of spatial files and image files that one can see. And we can go into more detail at another point. As you can see, there's so many different types there, it's hard to go through each one of those in detail. Is there another question at the moment?
One secondary question is, did you inherit the existing utility naming and symbol conventions, or was it revised, created for virtual Maine?
Can you repeat the question, please?
Did you inherit? Were you using existing utility naming and symbol conventions and simply pull that in, or did you have to create those for virtual Maine?
The symbol sets, as you can see for the utilities here, was something that an associate of mine created, and we wanted to have our utilities as closely associated to Canada as we could. And so we had a starting point, and yet all of those symbols were custom created. And as you can see, as you come down through the different utilities, that's a lot of symbols. And it's a lot of symbols to try to make unique, and I'm glad I wasn't the one that had to create those.
Thanks.
It did take quite a bit of time for the gentleman that did that to do it, and those are symbols that we can share with folks if they would like that, and save you a lot of time.
Great. Thanks. I'll let you get back to your presentation now.
So I've just turned on a couple things. Let me zoom out a little bit more here. During Hurricane Irene, we had shelters on, and so our live feed is with the Red Cross, and we can only see shelters with them when the shelters are open. Their feed doesn't actually show it when they're closed. And so what I'm showing you here is the centers that were open during Hurricane Irene. And we can see that we have a shelter pretty clear to these spots out here. And then the other ones are quite a ways away. And so we can see that we would probably want to bring people into this shelter. And one of the next things that we're going to want to know once we've done that is what types of medical facilities and transport options do we have. And so first we would want to see what type of transporting capabilities. So we have ground transport capabilities, and we can click on any of these, and it will bring up what it is, its address, contact information, and the level of service that they can provide. And each one of these is a little different. So if we need to drive, then we very well be able to do that. In some instances, there could be roads out or bridges down, in which case we'd need to have airlifts. And we have what are called light flights of Maine, and we have 4 of those. We have 2 up here in northern Maine. We have 1 in the Bangor area, and we have 1 down here in Lewiston. And if we were out in this area, we would want to be able to click on the light flight of Maine, and this will give us the contact information for them and the dispatch phone so that they could be contacted. The next thing that we would want to look at are the types of people that may be stranded, the type of facilities. So first we can look at, do we have any residential care centers? We can click on those and come over here, and we can see the number of beds, which is one of the primary things that we want to see, and then the type of care it is. And there's a variety of these here, and we can I did it again. So each one of these is going to give us the same screen, and it's going to tell us the number of beds that we have, which is one of the things that we want to know when we're transporting people, and we know the proximity to the shelters. And is the shelter going to be full? And we also can do the same thing for nursing homes. Brings up the information that we would want to see. This one has 50 beds, so obviously that would be a high priority. And I'm not going to go down through all the different types of care facilities that we have, but all the ones that we have are in here. And we also have, now, I'm showing this, for power outage, and this power outage here could very easily have been a result of the flood that was happening, which was up in this area. Or it could have been from a fire. This is all very remote out here, so it very well could be a fire. I wanted to show an example of a fire. However, the fires that we have in Maine generally are in structures. We don't have a lot of big forest fires like folks have out west. Another thing that we do have that is another real indication of the importance of being able to have a knowledge of where the, where did that go? Sorry. We had an airplane crash that happened out on an island, and it's not coming out for me. It did this to me yesterday. I guess I'm not going to show you that one. I'm at 22 minutes, and we were shooting for between 20 and 25. I can continue to show more data if you want. We have a variety of it. These are all our hurricane symbols, and again, you can bring it up, and it will tell you that who the person was, the name of the EOC that they're at, and what the information is that they have. Under our network links, we also have something that's really important, and we have all of our agricultural producers, which can be very important in the event of any type of emergency that you want to be able to see where your different farms are, and a lot of livestock and dairy cows and other things are dependent upon power. And they also can provide food.
I do have a couple of questions for you.
More I can show you. I can take questions. I'm sorry, go ahead.
Sure, I do have a couple of questions for you, Christopher. The first is, how much of this works if the Internet is down, say after an earthquake or a hurricane? What do you do? What do they use to access the Internet when power is out? Some of the viewers and attendees have had problems with this in the past during a tornado event or a hurricane event.
Sure. The data, we have 2 data centers in Maine, and they're at the state level, and they're at different locations, and they have their own power. And so we have this system on 2 different, what we call appliances, and the data centers have their own, significant power backup. So that will help if the power goes out. If the entire internet goes down, then the live feeds from places such as Usgs we will not have. A significant amount of this data is data that we have on different systems within the state, and we would be able to access that, assuming that we had power. Another thing that I'm not set up at the moment to show you, however, that we can do, and say, for example, you were interested just in this little area right here. You were going to send a team out into the field to look at these power outages. The product does have the capacity to take what you are seeing on the screen and clip that out and put that onto like a little thumb drive or an external hard disk, and then take that out and plug that into a laptop. It's called portable. And then that laptop can be taken anywhere, and you'll have whatever you've got in the globe, you'll be able to take out there, and then you'll be able to view it, and other laptops connect to that as well. So that'll show you the data that you have, and it will, any link that it's connected to, that it can go to and get access to that data, it will bring that data with it.
Great. And you're able to actually push this information. Folks who are in the field and are working off of mobile devices can access this data, and they can also report back to you on the current situation and do additional data collection for you while they're in the field. Is that correct?
Yes, and if you remember from my slideshow, the mobile data collection was our 3rd phase, and it's a product that we've just gotten into this summer. NEMA has been using the ODK toolkit, which was it's a free kind of form development toolkit that Google created and then put into the open source environment. And it's very useful for creating forms for gathering data. And we've been able to demonstrate that staff that are not computer experts, but rather just a different variety of roles within the NEMA or emergency response community can create forms and go out in the field and fill that form out in the field and hit send, and it will send that back to the home office using the wireless network. We are also very close to doing a test implementation of a product that's created by the Army Corps of Engineers called MICA. They used that during the floods in the Mississippi River Basin last year, and were able to capture 12,000 data points. And by data point, that can be voice, video, a still picture, text, and all of, so you can take a video, talk while you're taking it, type in a little text if you want, and hit send, and it sends that back to a server, and that server then takes that and creates a feed, which is then read directly into the Google Earth Enterprise environment. We're very excited about that because the Army Corps has created a very robust back end which brings in all that data and then creates the feeds for you to use. And you can organize those feeds by topic.
I've got another question for you here, Christopher. How did you integrate WebEOC with the Virtual Maine program? How does that data display?
So, well, this is WebEOC data right here. So this is from the incident log. So you can just click on it, and here it is. And if we wanted to see data from, these are the boards. So under WebEOC, we have mission tasks, shelters, county status, and the incident log. If I bring WebEOC over here, this is the out-of-the-box WebEOC control panel. These are all the boards that are existing, and they've just chosen to pick county, the mission tasks, the shelters, the county status, and the incident log using this application. The incident log is where most all of the events or situations are entered. And so that's how you would get to it. And if you double-click, it will go to that, and then it will show you the web EOC entry. One of the things that we're working on now is the ability to go the other direction. We'll be able to enter some data in from the spatial data that's actually captured in the Google Earth interface and send that over into a web EOC record that doesn't have spatial data. The data was transferred back and forth using the Google Maps API. Is the same API that's used for Google Earth Enterprise, and web EOC also comes with a very nice API, and we just were able to use primarily XML and SQL and just writing some very simple scripts to transfer the data back and forth. It was, the formatting of the bubbles and the symbols that people wanted to use took all of the time, not the actual going in. The web EOC is open. They're just Oracle tables behind the scenes. And the scripts and code and stuff that we've done to do that, we certainly can make available.
Great. I've got another question for you here. So from what you were saying, is the Office of Emergency Management and the individual agencies, they have the ability to see this data so that they can set up initial action plans and lines of command, correct?
Yeah, they can see it anytime they want. So right now it's been deployed out to the county level. And so anybody that has the Google Earth Enterprise client, which is similar in difficulty or simplicity, I should say, as the Google Earth that everybody else downloads from the web to install. And once they install the Google Earth client on their device, and it can run on notebooks and notepads and those types of things as well. And then once they have that, they have internet access, then they've got full connection to everything they have credentials for.
Great. Can you talk a little bit about the security and confidentiality? How do you maintain that? And also, to what extent are you able to push this information and what portions of the information out to the community itself?
That's a good question. So on the security side, within the state, we use Active Directory. And within Microsoft Active Directory, one can set up groups. And those groups can be set up to have access to specific types of data or databases. And in this case, as I showed earlier, this utility database here at the bottom is governed by Microsoft Active Directory. And with data that is on the outside, people from the outside would come in through HT Digest, and within that they would also be set up to determine which data they can see. The SWIM system that I have my mouse over here, the statewide incident management system, also requires a login. So to get where I am right now, I first have to log into Web EOC, and then I have to log into Google Earth Enterprise. And then I have to log into the state incident-wide management system. That gives me access to everything. Other people would do that, and then they might try to add this utility group, but they wouldn't get it because they wouldn't be in that group. There's a small number of people that are in that group. The Maine Emergency Management Agency controls who has access. They've decided at this point that we're not putting out a public group. I expect that may happen at some time in the future. What they decided was a very incremental deployment strategy of first within NEMA itself, which has been done, and then secondarily out to the counties, which is in process, and then after that out to the towns and to the various ambulance services and other EMT type of services. Those are the people that are going to be responding during an event. We wanted to make sure that that community had access first. Once that's done, then they will decide which portions of this data will be the most useful to put out to the public. Obviously, they're not going to put all of it out there.
let's go ahead and close out questions for right now. If you've got some final material to present or to conclude your remarks, Christopher.
Well, I think that there's a lot more to show. There's a lot of other data that I didn't show. I think a couple of things that I would say that are important is that in this layer, once you put data down in this layers section, you can't do anything with it. You know, if I'm up here in my places, you have the typical, you can do all this kind of stuff. This stuff down here is fixed. Nobody can add or delete it. One of the other nice things is that there's a lot of markup and mashup. I'm not going to go through it, but there's a lot of that you can do up here. There's a lot of the ability to add a variety of data sets. And we were able to get going really quickly. And we found that Google and some other contractors, we primarily worked with Google and NT Concepts and some other local folks that we work with to get this going. And it was only a matter of a few days once we actually got the appliance to have the thing up and running, and then we had a basic system. And so that's the real power of it. And then you just add data. You know, so we're in production now, and we just keep adding data. And one of the real things that I think is neat, and then I think I'm going to stop, and that is for data that's going to be captured in the field or data that might be added during an event or just during planning and other types of workflows. We have this network links section right here. And you can see now we have, you know, hazmat facilities, evacuation sciences, dams, agriculture, and so forth. What we have is a couple directories, and people copy things into that directory, and we have a script that just goes and reads that directory and then brings that into this network link. And so it's a very nice way of being able to have data come in through the organization. It's vetted by an individual. Then they just copy it into a directory, and the script just grabs that and runs that and reads that in here so that we don't need to rebuild the Google Earth project in order to add data. If we determined that some of this data was very large and that we might build that into the globe, because data that's built into the globe will draw fast the vector data if it's very large and a complex data set. We found that the Google community, the Google support groups, has been really helpful. We use that a lot when we're trying to try something new. And so the enterprise support is really helpful. And we're really happy with it. And our users are happy, and they just want more all the time, more data, more data.
Thank you, Christopher. It was really an engaging and interesting presentation. Christopher's going to stay on the line. We're going to turn now to Jennifer Montano, who serves as an enterprise geospatial manager for Google. Jennifer brings over 18 years of geospatial experience to the Google enterprise team. And she supports state and local government GEO initiatives. Jennifer will be joined at the end of her presentation by Alex Tinsley of DLT Solutions, a Google partner. Jennifer is going to be talking about some of the tools and resources available to help you build similar capabilities and talk about some of the solutions that she's already been working with in other jurisdictions. Jennifer?
Thank you. Can you see my screen?
We can.
Okay. Well, good afternoon, everyone. I wanted to thank Christopher for sharing his use case of how Google Geo Solutions are used for the state of Maine. It's a powerful and great case of how Google Solutions can be used. I'd like to spend the next few minutes outlining Google Solutions and then share with you some other state and local customers and how they're using our solutions today. Quickly, I wanted to discuss our design philosophy at Google. It's pretty straightforward.
Hey, Jennifer, can you click your Start Presentation tab near the top so that we see the full screen of the images?
Yes, sure thing.
Great. Thank you.
Can you see it okay? I'm assuming everybody can see that okay?
Yeah, there you go. Thanks.
Okay. So our design philosophy is pretty straightforward and really focused on 3 areas. One is providing easy access in order to share, and collaborate across mapping data. 2, we want to make those tasks that typically require complex GIS software or users simpler and easier. And then 3, we want to make geographic data useful and accessible to everyone in any location on multiple devices. And give me a second, this slide's going to build just a little bit. This is a high-level view of the Google Geo offerings today. Most agencies are familiar with our Earth and Maps API, but some are not familiar with the broader set of capabilities we offer. So I wanted to take 1 second and give you some figures that might be enlightening about the use of Google solutions today. Oops. There are more than 800,000 sites using our Maps API today. We have over 1 billion downloads of Google Earth. We have 200 plus petabytes of imagery data on our servers. And we have 300 million Gmail users a day. With this type of volume of users and data, you can imagine that Google has one of the largest and most secure set of data centers in the world. We offer a rich set of APIs and services on top of that to clients who want to build their own applications, like mapping, geocoding, directions, street view, tracks. We then offer a suite of solutions that are pre-built and ready for use, like Christopher was showing you. All of that at an entry point that best suits our clients, behind the firewall, in the cloud, or a mix of both, and of course, on mobile devices. Our cloud-based solutions provide emergency professionals the ability to create a common operating picture. We provide solutions that enable our customers to upload all types of GIS data, like you saw Christopher show, which can be which could be across multiple agencies, and publishing that information across our secure environment to the users who need to access it. Google's ability to provide this continuity of operations for valuable GIS data is really key during emergency situations. Our geo solutions also leverage the capability to publish once and view with many applications to really kind of streamline your distribution of key information. Information can be published to the public in an easy-to-use solution like Maps or Earth, while other information is kept private and for select authenticated users. And finally, we want to ensure that the mobile workforce is enabled through devices that they can use in the field to visualize emergency vehicles, equipment, personnel, add real-time inputs from the field, like you were asking a while ago, and do this from a connected or disconnected environment, depending on the situation. So let's talk a little bit about what makes our geo offerings different. One of our strengths is our ability to leverage and extend your current GIS investments with interfaces that are familiar to non-GIS users and to the general public. Our solutions are built to complement these GIS investments. We provide extensive and accurate geo data sets in case that's needed. We provide scalability, reliability, and security to key information. And we provide rapid, speedy applications, which are key in emergency operations. We're also dedicated to continually evolving our solutions so we stay on the forefront of what our customers are needing. One of our goals with our geo solutions is to ensure visualization of key data for non-GIS users and the public users. The next set of slides will be focused on how some of our customers are doing that today. Google Solutions are helping state and local agencies to provide affordable, scalable, and maintainable systems for key GIS data. We're also enabling the field operations with real-time information and enabling agencies like Homeland Security, law enforcement, and health with powerful situation awareness and easy-to-use visualization solutions. Washington, D.C. uses a combination of Google Solutions to provide real-time intelligence to public safety and fire professionals. They also enable the public to see data such as crime, permits, schools, etc., as you're seeing on the screen. This solution was utilized by over 200 responders across federal, state, and local agencies within the 2009 inauguration. The state of Florida created an emergency management application to provide the public with information in advance, during, and after a natural disaster. This application utilizes a combination of Esri's back-end GIS system with Google's visualization solutions to display a variety of federal, state, and local information. We'll actually provide the link after the webinar, but you can go out there and you can actually see the hurricane that's coming, or potential hurricane that's coming, and all of the preparation that's going on in Florida. The City of Charlotte also chose Google Solutions to extend their Esri deployment to provide over 100 layers of information to non-GIS and public users. And by doing so, they saved a significant savings in legacy GIS costs. The state of Alabama, Virtual Alabama, was created to do a statewide repository of GIS data and imagery across 550 agencies to create a common operating picture and enable emergency operations. I'd like to highlight the San Diego Red Cross and their end-to-end use of Google Solutions to provide a common operating picture for emergency operations. By using a combination of Google Apps and maps, they were able to bring together all types of real-time information, from the status of the shelters to the status of shelter volunteers, negotiated food vendors for the shelters by time of day, gas stations, status and location of emergency vehicles. It is an amazing use of the many Google solutions that we offer. So just a note, we have case studies and videos and web links available that we're going to share after this presentation for those who are interested in learning more and greater detail about each one of these use cases. And lastly, one item that we can't ignore is social media. State and local agencies are not only empowering their citizens with GIS data through the use of our solutions, but also incorporating back information into the agencies from social media channels. This is another powerful way that emergency professionals can enhance their ground truth during emergency situations. Alex, I think I'm turning it to you now.
Yes, I am here. So go to the next slide. This is Alex Tinsley from DLT Solutions. We had heard from Virtual Maine. We've seen Charlotte. We've seen Alabama. We saw San Diego Red Cross. We've seen how Florida uses it all. They use a robust set of tools and put out the GIS information because it's everywhere. It's simple. It's already used by people. Like you said, there's 1 billion downloads every day. We can push it out mobile, push information to the users. We can get information back using the social media with the general public. We can get it back from the personnel that's out there in the field. It's near real time. We support the community engagement doing that. It's cost effective. That's the biggest thing, and it's secure. It provides continuity of operations, and it allows you to optimize the common operating picture for your environment. You saw how all the 5 different places we've seen, especially Virtual Maine, where they've been able to put it to what they need it for and how they want to use it and put it out to their public. Any questions?
Great. Thanks, Alex, and thanks, Jennifer. We do have a couple of questions pending. And it really kind of goes back to the last point you made, Alex, and it was certainly impressive, Jennifer, when you were going through the slides. The image we saw from Florida is very different from the image we saw in Maine. These are both using some of the same resources, but is that an example of the fact that you can optimize this and customize this really to your specific jurisdiction and how you want the image and the visualization to appear?
Yeah, that's really a great question. And we do, like I said before, we offer a variety of solutions. The state of Florida is using a slightly different solution than the state of Maine. And then on top of that, you can customize it for whatever look and feel you'd like and make it sure that it's very easy to get at, very visual for the people to understand.
Great. Another question, just in terms of...
I'd like to make a comment, if I could. This is Christopher from Maine. One thing that is important, I think, to note that we're using Google Earth Enterprise on our own servers. You can also use a map engine which Google provides, which is similar, however, it runs out in the cloud, and you can You can customize the look and feel of that a little bit more, and you can use Google's data center as an operating environment and not have to have your own. Thanks.
That's absolutely right, Christopher. That Maps engine solution allows you to publish this continuity of business in the cloud and allow other people to be authenticated to see the information, just like Christopher did, but just a slightly different process. And then you choose the front end to that data, whether it be maps, Earth, a widget, or some other type of way of getting at that information.
Brilliant. Can you talk a little bit about just how accurate Google Maps are and what's the depth and breadth of coverage?
Right. So after this webinar, we can certainly provide you all that type of information. Let me just say at a base level that Google creates their own base layers of information. And we have a utility called MapMaker, where the community is always updating and editing this information to provide real-time updates. And you can actually go out and watch this be updated live if you'd like to see that link.
Are there limits? Let me ask you, Jennifer. Are there limits on the size of data sets, on how much information can be pushed to the platform and visualized?
Actually, there's not. We have cases where someone has gigabytes of data, and then we have someone who has maybe 50 terabytes of data. So usually it's like legacy historic imagery. So we're not limited on the size and type of GIS data.
And are there any platform? What kind of platforms can you plug into Google Maps? And what about exporting of data?
So again, Maps Engine kind of takes in a variety of formats, whether it be shape files, MapInfo tab files, all these different formats that Christopher showed you. And it stores them in their native format. So you can push and pull in its native format. Again, we can get into more technicality on separate discussions on some of these things.
Sure. Any other questions from the folks who are attending the webinar, either for Christopher or for Rebecca? Christopher, can you talk a little bit about the current status of your program and what some of your next steps are going to be?
Sure. So as I mentioned, the current status is we are in production in the MEMA and in the Emergency Operations Center, and it's being deployed out into the counties. Our current work is focusing on a few different areas, integrating with the Red Cross's dynamic shelter system and being able to have assets that come on to the globe just with a town for location. Often people will be out in the field. All they'll know is they're in a particular town, and that's all the information we'll have that will come in at the center of the town. And we're developing a tool where people can then move that visually to the place where it belongs, and it will write that location back into WebEOC. And then finally, the mobile devices are where we're really looking forward to doing the most of our work. Again, I mentioned the MICA system from the Army Corps of Engineers and also the ODK toolkit. And then with Virtual USA, and one of the nice things that I didn't mention that I think is important as well is that you can bring multiple globes in. So different, the Red Cross could have a globe, and we can have a globe, and other people can have a globe or a database, and you can bring those all in to different people's systems. So you could have a system, for example, and if we gave you access to our database, you could bring it into yours. So maybe you wanted to send help to Maine, or maybe someone down in Florida wanted to give us access to their database so that we could know what was happening to send people down there to help.
Great. Thank you, Christopher. Thanks very much. We're just about at the end of our time. I want to remind everyone that we have recorded this webinar. It will be archived, and will be DLT Solutions will be sending this out to everyone who's registered for the webinar within the next couple of days. I want to thank all of you for your contributions in providing a very informative webinar. Special thanks to Christopher Crute of the Maine Office of GIS, Jennifer Montano of Google, Alex Tinsley of DLT Solutions and to emergency management for organizing this event. Thanks very much for participating, and we look forward to hearing from you in the future.